angular and polar coordinates and equations. We want to also be able to graph, which is, I'm not going to lie, not the easiest thing in the whole world to do. But we will do some stuff on the calculators. But I want you to be able to graph some basic ones, and tomorrow when we do day 2, we'll talk about how we can look at the equation and we can figure out what shape it's going to be before we graph it, which makes things a lot easier if you know the shape ahead of time. It helps you in picking the points. But today we're going to, struggle through it and not know the shape unless you read your book on your own. That's good, right? This is not going to happen. That's cute. Look at this lovely graph I put here for you. I even labeled the angles for you. Hey, I realized remember yesterday when I was graphing the point and then I reflected it and then we had a big disagreement on where the point should be? I graphed the point down here wrong. Right? Like it was like, I just want to say, it was supposed to be 306 degrees and it had a bunch of lines and I totally graphed it at like the 45 degree mark and not the 30 degree mark. Which is why when I reflected it, I was having issues up there because it wasn't the right point down here. So I'm just saying.
Apology accepted.
Okay. In 6th hour, we had the same issue, and they all got up. There's only 9 of them, but 7 of them got up and came to the board, and we were all arguing about where the point should be.
They were right.
And then Chase said my point was wrong. And I was like, oh.
Yeah. So Chase says it goes.
Well, no, I fixed it, or I did the math again. And I was like, oh yeah, that's 45 degrees. So I was still kind of wrong. I mean, I was wrong either way, but.
Then you're just double wrong.
I was double wrong because I grabbed the point wrong. So. I think the lesson is just figure out the new angle by adding pi and skip reflecting. That was my lesson that I learned.
If you're gonna reflect the picture,
Instead of x's and y's, I think we need to make our data chart here. So we're just going to go through this. Remember the first time we graphed sine and I made you pick 8 million points? We're going to pick a lot of points here.
That's not good.
Let's pick 0. What is the cosine of 0? 2. So, I mean 1, but times 2 is 2, right? 2 times cosine of 0 would be 2 times 1, which is 2. I'm not going to spend a lot of time going through the unit circle values because I expect that you know them, or you have a calculator that could just give you the decimal, right? What if I did pi 6? What is the cosine of pi 6? Radical 3 over 2 times 2 would be radical 3, which is like 1.71. Is that true? Who knows the square root of 3 is a decimal?
No one.
Oh, 1.73. We'll just keep the 1.7. Old people do because they had to memorize them. Find someone old and ask them what the square root of 3 is.
What should I like?
I'm not that old.
Okay, that's how you have.
No, but when I was in school, I had teachers that knew the square root of 3 to 12 decimal places.
That's just you.
Because they didn't have calculators. Yeah, they had a chart in the back of the book that had square roots and decimals.
You know what a slide rule is?
I do.
My grandpa got one.
There used to be a big giant slide rule that was in here, and someone got rid of it.
Slide what?
This
It
was
looks like it's split. A slide what?
a slide rule. They used to use it to approximate square roots and logarithms and things that now you just have in your calculator and get a decimal, but they use this and they would slide it different ways and you can approximate values. So. Pi fourths, what's the cosine of pi fourths? Square root 2 over 2 times 2 is square root of 2, which is like 1.3. I don't know.
No, it's 1.4. 1.1.
Someone did.
1415. 414 200
What about pi thirds? The cosine of pi thirds is 1/2 times 2 is 1. What is the cosine of pi halves? Is 0 times 2 is 0. So let's graph some of these. So I kind of like to write r and then theta, even though we plugged theta in, because now we have to figure out when we graph this, right? We normally think r theta. But if I have a radius of 2 and a theta of 0, that would mean on the second circle at 0 radians. You agree with that?
So it's in radian mode now.
I'm in radian mode. Just because there's radians around here. But I can just kind of go around, we did all these, right? At pi 6, it was 1.17. How do you graph a radius of 1.17? I don't know. More than 1.5? I'm going to say about right here. Pi fourths was 1.4, which means it should be a little less than that. And pi thirds was 1, which would be right here. Yes? Oh, we're getting there. And at pi halves, it's 0. How do I graph that? If the radius is 0, no matter the angle, it's going to be right here. So let's think about what we know about trig functions and what we know about angles before we pick every angle on this circle.
It's gonna be a really cute one. Like I'm wrapping up the
Cosine is positive here and where?
Down there.
Cosine is positive in the first and the fourth quadrant, which means if I pick these same angles down here, am I going to get the same R values?
Yes.
You see what I'm saying? So if you think about that, it can save you a lot of time. So instead of having to pick 11 pi 6, do I know that 11 pi 6, it's going to also be at what it was at pi 6? Does that make sense what I'm saying? So I could say that I know that that's going to be 1.7.
One of these, like, one of these actions here. The heart, kind of the smash.
Pi fourths and 7 pi fourths for cosine have the same value because they're both positive, which means it would be 1.4. And at 5 pi thirds, it's also going to be at 1. Oh, that didn't work out so well. And at 3 pi halves, it's going to be back at 0. But what about all these values over here? What do we know about cosine in quadrant 2 and quadrant 3? They're negative. So let's think for a minute. Let's pick a nice one, like pi or 2 pi thirds. What do you want to do?
Pi.
If we pick pi, what is the cosine of pi? Negative 1 times 2 is negative 2. But how do I graph a negative r?
You flip it.
You flip it. So if it's over here, but it's negative, is it just going to reflect back to a point that I already have? Does that make sense? All of these values for cosine are negative, which means they're just going to give me the negative r values, which means they're all going to just flip. All the ones up here are going to flip down here. All the ones over here are going to flip over here. Which means even if you go around this whole circle, we're never going to get more points than that. Follow me on that? What kind of shape is this? I kind of messed up.
Octagons, I think, here.
This was 1. This is supposed to be 1.4. This is supposed to be 1.7. I think it's just a circle. It's smooth curve, not jagged. Like, don't make pointy edges.
I thought it was a decagon.
It's just a circle, a little tiny circle. That's a lot of work for a circle, right? Whew. I think no, because there could be other stuff. But yes, we're going to talk about if you just have r equals a number times cosine, it's going to be a. Whew. Okay. Moving on. What else can help us before we just start guessing random numbers is that we can think about finding the maximum value of r to help us know how big our graph is going to be. Not all graphs have a maximum, but if you have a function that has cosine or sine in it, it's going to have a maximum value, because what is the biggest value that sine and cosine ever will be? 1. So when they ask you to find the maximum value of r, they want you to use the fact that you know the cosine of any angle is never bigger than 1, right? Cosine of theta is always less than or equal to 1. We can find the minimum value if we wanted to, but then it's negative, so if the biggest this can ever be is 1, yes? Could I say the biggest that r could ever be would be 2 plus 2 times 1. Or I could say the biggest value would be 4. Could be real fancy and tell me where that happens. Where does cosine equal 1? Zero. We could probably say at, not at pi. Pi wouldn't work on this one, right?
2 pi. 2 pi is also
2 pi is the same as 0, right? But yeah, we could just put that. I don't think they really want you to say that. I think they just want this. There's a couple problems on your homework that just say find the maximum value. Be careful. They could trick you a little bit. In that, what if this said 2 minus 2 cosine of theta? Is plugging in 1 going to give me the maximum value of that? You see what I'm saying? If you plug in 1 for cosine here, you would get a value of 0. Can this ever be bigger than 0? Because what? What could I plug in? What if I plugged in negative 1? You see what I'm saying? Like how it's either going to be 1 or negative 1 that you're plugging in. It just depends on what's in the problem, whether it's positive or negative. We'll talk about those tomorrow if you have questions on them. I don't ever really use the maximum value to help me graph, but they ask questions like that, find the maximum value. So that was like an extra great example. Let's graph a crazy one.
That one was pretty crazy. I don't know.
That one was crazy. Why didn't I number this one? It's a real question. Shakespeare's birthday today. Very big deal. 450, right? Like that's what I
I think Nicola about this one.
Orange potatoes? Why didn't I put a graph on here? Oh, I think I put it on the next slide, right? I'm going to double page this. Can you see that? Can you see the one on your page? Oh, it won't let me make it bigger. What should we start with? 0. What's the cosine of 0? 1. So 4 minus 3 is 1. Are you with me on where I'm getting those values, or you think I'm just making stuff up here?
A little bit of both.
I'm just plugging that in. 4 minus 3 cosine of 0. If you're really, really bad at trig, you're just graphing, so I don't care about decimals. Like, you can type in your calculator. 4 minus cosine of 0. And it'll tell you the answer. No brain work involved. What? Yes. I don't know how many points we need to pick. We gotta pick a few though, right? But do we need to pick every point? I don't know. Let's pick, I don't know, pi 6? Pi thirds? Pi fourths? All of them? The good news is we can do this reflecting thing again at some point. I'll have to think if it works as easily as the last one. But definitely when the quadrants, like quadrant 1 and quadrant 4 for cosine are going to always have the same points. Do you agree with me on that? So that means every point that I get in quadrant 1, I know is going to be in quadrant 4. We can use that idea of symmetry to help us. Pi 6, the cosine of pi 6 is a square root of 3 over 2, which means I'm going to have to use my calculator because I don't know what that is if I had. Someone do it. Someone type it in their calculator. 1.000685. We're just gonna say. Yeah, I get 1.4.
Yeah, I got 1.4.
I just typed that in, just like that. If you're typing in the cosine, then yes, you have to be in radians if you're typing pi 6 then, right? Like if you're typing an angle in radians, you have to be in radians. I have an angle in degrees, you have to be in degrees. I'm gonna skip pi fourths for now, we'll come back if we need it. But I'm gonna go to pi thirds. The cosine of pi thirds is 1/2. That's not 3 1/2, that's 3 times half. Or yeah, 1 1/2. So that's 2 1/2, is that true? Pi halves. Cosine of pi halves is 0, which means I just get 4 from that. So at 0, I get 1. Make sure this has a lot of lines on it, right? So this is where I screwed up yesterday and I graphed wrong. Pi sixths is here. This is pi fourths. This is pi thirds. So it's really going by pi twelfths. So at pi sixths, it's 1.4, which is roughly about there. And at pi thirds, it's 2.5, which would be like right here. And at pi halves, it's at 1, 2, 3, 4, which is right here. And I still have to do some more work, but again, using what I know about cosine, cosine is positive in quadrant 1 and quadrant 4, I know I can take these points up here and reflect them down here to quadrant 4. So, I know at the pi thirds one, which would be here, it's at 2.5, should be like this. And I know at negative pi 6 or 11 pi 6, it's at 1.4. And I know at 3 pi halves, it will also be at 4. So it's kind of like a 2-for-1 deal on these points. No, we had to do the other side, right? On the last one, it was just a number and cosine. So all of them were just going to give us the exact opposite value. But when there's a number added or subtracted, we're going to have to do some negative values here because it's not going to be the same. Like if I pick pi for this, what is the cosine of pi? -1. So I don't just get the opposite, right? Like I actually get 7. So at pi, do I even have 7 on here? 1, 2, 3, 4, 5, 6, 7. That would be my max value on that one because of the negative.
Umbrella right now on the side.
And I also need to pick some other points. I'm not going to pick a ton here, but let's just go the thirds and the sixths again. So let's do 2 pi thirds and 5 pi sixths. And again, in radian mode, you can type that exactly in your calculator. That you can type in 4 minus 3 times cosine of 2 pi thirds. And I'm in degree mode. 5.5. And again, why are we not getting the exact opposite? Because we're getting a negative number, which is now changing that -3 to a plus, and we're adding it to 4. So we're actually getting a bigger number. Does anybody else get 5.5? So this is a third, so 1, 2, 3, 4, 5.5. And when I do 5 pi 6, the cosine of 5 pi 6 is -1/2. So then I just get 4 plus 3 halves.
5 1/2. That's not what it was.
6.6. I did this backwards, kids. Just kidding. Right? This is 1/2. This is radical 3/2. Like this. That's why this is 5 1/2. And this is 6.6. Wait a minute. Where am I at? This one. 1, 2, 3, 4, 5, 6.6. Goodness gracious.
This one is much harder.
This is one of the what?
Much harder things on its side.
It is a smushed heart thingy on its side. How do you know what this is called?
Smush harder side.
I know, but how do you know that? Like, because you're just saying by the way it looks?
That's what the graph is.
Oh my
I
gosh.
want to know how you learned that. What it looks like.
I saw it.
Oh, you saw a picture. Okay, you read your book. That's good.
How do you pronounce it?
It's a, no, this is called a cardioid, actually.
That one right there is on 6.3.
And it's easy to remember that it's a cardioid if you remember that it looks like a
vasculus.
heart, right? But it,
That's right.
The curve.
Look right there.
L.
limnoscate? I don't know. Is that the one you're looking at? This is not a limnoscate, though. Yes. Quadrant 3 is negative just like quadrant 2, right? So I can just flip those down. Oh, I am impressed. Not jagged, okay?
Because hearts aren't sharp.
Except for that one point there. It is called a cusp. That is called a cardioid, and it's easy to remember because it kind of looks like a heart on the side.
Big old fat heart.
Tomorrow we're going to talk about those names a lot more, but... And, again, you're going to see that when you have numbers like this, there's actually a rule to how to know if it's a cardioid. But if this number is bigger than this number, it's going to be a cardioid. We'll talk about that tomorrow. It's a little bit of work to graph them, yes? Do I have another one to graph? Whew. This is different than the assignment sheet that I just gave you yesterday, but I took the problems off, if it makes you feel any better. So all of these problems are on there, but there's just a few less. Like I think there's like a 13, 14, something like that you don't have to do, because I'm not going to waste time teaching you symmetry rules when we can just look at the cosine to do that. These three, I want you to graph. Maybe you also have to graph number 3. Is that true? Let's look at this here. I'm going to give you graphs, yes. Number 3 says draw graph, so 3 is a graph. Yeah, so you have 4 graphs that you're going to make, and I'm going to even help you start number 3, okay? Hooray! And even so, great, I have awesome graph paper that has room for you to like make your chart next to, and it's even red so you can see it with your pencil. So.
Last time should have said around.
I know. Well, there's 4 of them, so I'll just give you. Okay, there might not be all red ones.
Oh no.
Oh man.
I got a red one. I got a red one. I got a red one. I got a red one.
There's a hole you're not getting. So if you want, you can do your whole assignment on this, because there's only 2 other ones that aren't graphs. But it's up to you. You gotta keep track of this. Or if you want to cut them out and take them on your paper, okay. But get your paper labeled or whatever. Number 3, I want you to look at it. Boys, I'm doing number 3 with you. Get your paper ready. What looks weird about number 3? This always freaks people out because they don't know what to do. But you can just pick whatever you want, right? And just multiply that by 3. Does that make sense? The hard part is if you only pick nice angles, you're going to get the same thing over and over again, and then people don't know what to do. So here's my thetas. Here's my r's. If I pick 0, what is the sign of 0? 0 times 3 is 0. What if I pick pi 6? You would take 3 times pi 6, which is pi halves, and the sign of pi halves is 1, and 1 times 3 is 3. Did you get that when you typed in your calculator? If you typed in your calculator, you would do 3 sine of 3 times pi 6. So just pi halves. What if I did pi thirds? Pi thirds times 3 is pi. What's the sign of pi? 0. I just get 0 again. And what if I picked pi halves? I would get 3 pi halves, which is negative 1 times 3 is negative 3. And you get a bunch of these answers, which means you have to pick different angles. You have to pick maybe angles that aren't so nice things that you can just type in your calculator. This one, did we decide what this is going by? Remember how we cut this down? Like this is pi 6. So what's this? Pi 12ths. Maybe we should pick pi 12ths. Pi 12 is just pi fourths, right? And so sine of pi fourths is square root of 2 over 2, which means you get like 2.12. So let's see what we have here. We have 0, 0. We have pi 6, 3. We have pi thirds back to 0. We have pi halves negative 3. How would you graph pi halves negative 3? So like it would be like down here. I'm just getting a bunch of points here, right? It's not, that's why we're doing this together. Oh yeah, yes. Are you in radian mode? 3 times pi 12ths. I really think you should get that. 2.12. So at pi 12ths, I get 2.12. What's going to happen if I plug pi fourths in there? It's going to be 3 pi fourths, and is the sign of 3 pi fourths the same as pi fourths? Yep, which means I'm going to get 2.12 again.
One of these. She got really excited about it.
So I think in quadrant 1, like pi thirds, we just got 0. Like in quadrant 1, we get this lovely little pedal here. The question is where you're going to get the other pedals. We're going to talk about this tomorrow. Like tomorrow's going to be like the shortcut. But here's the big thing. If you get a length of 3, you see how this one was out here at 3? That means on either side of that, you're going to have the 2.12. You're going to have the pedals with it. And you can check that if you pick these pi 12ths here, you're going to get that 2.12 again. So there's another pedal. The question is, where else am I going to put a pedal? What about pi? If I pick pi, am I going to get a 3 over here? Nope, I'm just going to get 3 pi, which is negative, which is going to just flip me back over. It's not going to be anything, right? It's going to be like 0, actually, I guess. Just kidding. What about up here? Am I going to get a pedal up here at some point? What can we pick? What if I pick 3 pi halves? 5 pi 6? Right, because 3 pi halves is going to give you negative 3. So it's going to flip it back up here. And here's where we're going to go with this tomorrow. I think we need more. I'm going to let you keep working here. Tomorrow we're going to talk about what these numbers mean. One of these numbers means how long the pedal is. A length of 3. The other one has to do with the number of petals, but I'll tell you this is not the number of petals. There's more petals than 3. So what I want you to try on this is probably the hardest one on your homework. See if you can pick some more points and see if there's some more petals around here. No. Okay? But 25, 28, and 32 are not that difficult. One of them is a circle, one of them is a line, and I think one of them is a cardioid. Alright? So if you get stuck on number 3, do the rest of your homework still. Okay?